What does it mean when a comet seems to breathe, out past the comfort of our warmth, beyond Mars, where sunlight is more suggestion than heat? A wanderer from another star exhales into the dark. 3I Atlas is venting water and strange greens, flashing a chemistry that shouldn't wake at this distance. Our comets hibernate here. This one behaves. It brightens, shifts color, and throws off clues like sparks from a cold forge. Astronomers have a phrase for it, half joke, half confession. It's acting alive. Tonight, we'll ask why, and show you how we know. You'll hear the evidence, not the echo. The ultraviolet halo swift detected, the superlinear rise that feels like someone flipped a switch, the nickel lines blazing without their iron companion. You'll learn why those facts matter, what they imply about where this traveler was made, and what sort of star might stamp such odd signatures into its ice. But we're not here to sell you fantasies. We pace ourselves with reason. The voice will stay slow, the data precise, the metaphors earned. This is a documentary for rest, not frenzy. A clear window you can lean against while the universe moves. Still, a trailer plays in your head. Cyanide lighting the coma green, jets hissing from fractures as the nucleus turns. Thresholds crossed like doors opening down a long hallway. You are watching a natural body perform unfamiliar moves, and the choreography may rewrite old rules. If 3I Atlas does out here what our comets only do near the sun, then formation, layering, and hidden volatiles are telling us a different story about how worlds begin. Here's the promise for staying. By the end of tonight's chapter, you'll be able to explain, calmly to anyone, why this object is unusual without reaching for the paranormal. You'll be able to picture its path, its possible birthplace in an older slice of the galaxy, and the mechanisms that could make water whisper and nickel sing when iron stays silent. You'll have language for wonder and tools for doubt. So settle in. Let the room dim and the pace lengthen. Imagine the camera drifting beside the comet as it turns, breath fogging in a vacuum that should not permit breath. No soundtrack needed, just a steady heartbeat of numbers, a few careful hypotheses, and a sky that keeps its secrets until we have earned them. And if you find yourself relaxing, that's by design, learning at the speed of sleep. We'll trade hype for clarity, fear for curiosity, noise for signal. Because the universe is generous to listeners, and 3I Atlas, whether messenger or mystery, will speak in a voice you can trust tonight. The first sign didn't come as a photograph. It came as data, soft, rhythmic, like a breath you could only see in numbers. Swift's ultraviolet telescope caught a faint halo around 3I Atlas, hydroxyl, the ghost of water broken apart by sunlight. At a distance of 3 P1 astronomical units, where ice should be locked solid, the comet was releasing 40 kilograms of water every second. That shouldn't be possible. Not out here, where the sun is only a pale coin in a black sea. Yet the readings repeated night after night, until disbelief turned into calculation. Astronomers double-checked the math, then checked again. 40 kilograms per second, roughly 10,000 gallons an hour, wasn't a leak. It was activity. It was the difference between an object coasting silently and one that seemed, in some small way, alive. Some compared it to 2I Borisov, a comet that behaved by the book. Others pointed to Oumuamua, dry and cryptic, shedding nothing at all. 3I Atlas stood between them, a performer in motion, Refusing to pick a side, imagine standing where the solar wind whispers against the void. You would see it there, faintly blue, a dim sphere of light swelling around a heart too small to see. That glow, the hydroxyl signature, tells us water molecules are being split by sunlight. Though the comet sits beyond the frost line where the temperature barely reaches -150 degrees Celsius. At that range, even carbon dioxide sleeps. And yet, somehow, this object stirs. The data looked like a pulse, a repeating curve of emission that rose and fell as if following a heartbeat. The team at Goddard described it as persistent variability. They meant it won't stop doing this. And the more they watched, the more it seemed to know it was being watched. When the analysis was published, new measurements came in. Brightness increasing slightly, jets flickering. To some, it was coincidence. To others, response. In the public mind, the story grew a life of its own. Was the comet venting ancient ices trapped under strange pressure? Was it rotating in such a way that hidden pockets of gas briefly met sunlight? Or was there something subtler? A chemical layer so volatile that even distant photons could wake it. Each theory tried to fit the curve, but none explained how the energy budget balanced. It was as if 3i Atlas had found a way to act warmer than it should be. One scientist compared it to an animal stirring in its sleep, muscle memory of a star it once orbited. Another said, almost apologetically, it's just physics we don't yet understand. Both are true in their way. The key is that it isn't fantasy. It's measured. The numbers are real. The uncertainty is real, and that combination is what makes science irresistible. The impossible becomes a question, not a miracle. In the recordings, you can hear the signal converted to sound, a gentle oscillation, steady and low, like waves on a frozen shore. It isn't music, but it feels composed. The hydroxyl hum, rising and falling against background noise. A heartbeat hidden in light years. If you let yourself relax into it, you might mistake that rhythm for language. It's not. It's chemistry, sunlight, and motion, but they speak together in ways that feel personal. So the mystery stands. 3. Atlas. Too far from heat to boil, too active to be still, breathing out a mist that shouldn't exist. A comet is supposed to reflect light, not respond to it. And yet, here it is, reacting, performing, almost conversing. The question lingers as a promise. If this is only the first act, what will it do next? It's not just moving, it's responding. When the spectra first arrived from the Very Large Telescope, the lines looked ordinary, thin bright strokes on a dark background, a cosmic barcode. But as the analysis deepened, something subtle began to stand out. Nickel lines, clear, confident, undeniable, shone where iron should have been. The element that usually walks beside nickel in every comet, every meteorite, every planetary crust, was missing. Nickel without iron is a chord with half its harmony gone, a melody stripped of its bass. Astronomers stared at the data and wondered if their instruments had blinked. They checked calibration lamps, ran simulations, even replaced the detectors. The lines remained. The absence of iron wasn't noise, it was truth. It's as if the comet carried a composition from a world that cooled differently, a place where the familiar pairing of nickel and iron was somehow broken. In the periodic table, they sit shoulder to shoulder. In the cosmos, they are usually forged together, their ratios nearly fixed by the physics of supernova. Seeing one without the other is like hearing thunder with no lightning, footprints without feet. The first theory was temperature. Maybe the nickel came from compounds that evaporate slightly easier than iron. Yet the numbers didn't fit. At the measured distance from the sun, both metals should be locked in the comet's dust, bound in silicates and oxides that only release when the heat is fierce. 3 hours Atlas was too far away, too cold for either to appear, and yet one was there, singing solo. That alone would have been strange, but the clarity of the nickel line was even stranger. Strong, narrow, steady, like a held note that doesn't fade. In the research rooms, models multiplied. Some suggested microscopic grains with surfaces coated in pure nickel. Others thought the metal might have been segregated during the comet's birth, iron sinking inward, nickel staying near the crust. A few whispered about unknown reactions triggered by cosmic rays over millions of years between the stars. Each scenario explained a fragment, none explained the whole. Whatever the answer, it pointed back to formation, to the chemical fingerprint of a system not our own. If you could listen to the light instead of see it, you'd hear the nickel tone, a bright metallic hum rising from the darkness, clean and unwavering. Then silence, where iron should reply, a duet that never resolves. The mind tries to fill in the missing note, just as the scientists tried to fill in the missing element. That longing for completion is human. It's why anomalies keep us awake. The more they looked, the more they felt the gap meant something. In chemistry, absence can speak louder than presence. Nickel without iron implies a memory of an older furnace, perhaps one where the balance of elements was skewed by time or temperature. Maybe 3I, Atlas, was born in the debris of a dying star, whose explosion unevenly scattered its metals. Maybe, drifting through eons, it lost what was heavier, keeping only what could cling to frozen dust. Every possibility loops back to a single truth. This object is built from a recipe we haven't tasted before. The report from the European Southern Observatory was cautious, the way scientists are when standing at the edge of the unknown. They noted the ratios, the signal to noise, the comparisons to comets like 67P. But between the lines lay something more poetic, a quiet admission that nature had composed a new arrangement, a score where familiar instruments play in unfamiliar order. To visualize it, imagine footprints pressed into frost, one deeper than the other, leading away from a place you can't see. That's the data, traces of a process walking out of our comprehension. We follow them because they hint at a story larger than their shape. We follow because they are beautiful. And as the analysis continued, something subtle shifted in tone. The scientists stopped asking why iron was missing and began asking where this music began. Nickel without iron, hydrogen without ice, signals without heat. All these fragments orbit the same question. What kind of birthplace could forge a traveler like this? The next step would take them beyond chemistry into galactic geography, a journey to the regions where stars age differently, where metallicity thins and time slows. To find the origin of 3I Atlas, they would need to map the echoes of its missing element. It leaves chemical footprints that shouldn't exist. As 3I Atlas drifted inward, nothing much changed at first. Its brightness held steady, its spectral lines calm, its behavior predictable. Then, over the course of a few days, something remarkable happened. Without warning, its coma flared, swelling by a factor of 2. Cyanide emissions, faint before, leapt upward like a spark catching dry tinder. Telescopes registered the shift as an exponential curve, no gradual incline, no gentle slope, just a sudden ignition as if a switch had been thrown somewhere deep inside the comet. It switched on, instantly. This kind of activation doesn't belong to physics as we usually know it. Thermal models predict smooth transitions, matter easing from frozen to vapor as sunlight warms its surface. But what 3 Atlas did looked more like a threshold. For hours, it slept. Then, at a precise distance from the sun, everything changed. Dust jets erupted from hidden fractures. Molecules invisible before now painted the ultraviolet spectrum bright green and blue. The flare wasn't chaos. It had structure, timing, rhythm. Like a heartbeat that had just resumed after a pause too long. Observers compared notes across continents. Each record showed the same pulse, a leap in brightness, followed by a measured settling, then another leap days later. The pattern suggested feedback, a cause responding to its own effect. To some, it resembled a machine test, systems booting after long dormancy. To others, it was nature's own version of curiosity, a frozen object reacting the instant it re-entered awareness. It's not that it knew we were watching, but the timing invited the thought. It acted as if observation itself were part of the trigger. If you listen to the data translated into sound, it hums, a soft electronic blip repeating at irregular intervals. Each blip marks an emission spike, a breath in the dark. Between them, silence stretches long enough to make you doubt the next will come. And then it does, clean and sudden. The pattern feels deliberate because it's discontinuous. Linear systems drift, non-linear ones surprise. The universe loves surprises. Scientists tried to anchor the anomaly in chemistry. One idea proposed that the comet's crust was layered like tree bark, each stratum holding different ices sealed by dust. As the outermost layer eroded, sunlight reached deeper volatiles, carbon monoxide, cyanide, maybe even ammonia, and the reaction cascaded through buried reservoirs. The result? Abrupt bursts of outgassing, each opening a new valve. Another model suggested electrostatic charging, the comet building up potential until it discharged in a flash of ions, briefly lighting its halo like static before a storm. Both theories fit pieces of the puzzle, neither the full picture. What fascinated researchers was the apparent precision of the trigger. The first outburst happened at roughly 3.2 astronomical units. The second, stronger one, closer to 2.9. These aren't random numbers. They're thresholds where sunlight intensity doubles, where molecular bonds cross the fine line between stillness and motion. To describe it plainly, 3I Atlas behaved as if built to wake only when certain conditions were met. No warming curve, no warning, just light. In the calm voice of a report, this might sound simple, but under that calm lies wonder. Imagine an object frozen for millions of years between stars, suddenly tasting heat again, remembering movement. Its layers cracking open, whispering chemistry into space. For the first time since it left its home system, it reacts. Every molecule released is a signal. I'm still here. The act itself feels conscious not because it is, but because it's timed so perfectly with our gaze. What happens inside those cracks remains a mystery. There's talk of microcavities, pockets of super volatile gas that accumulate charge as the nucleus spins. When sunlight hits a certain angle, the pressure surpasses a critical point. The wall collapses, and the gas erupts like breath through parted lips. The cycle repeats, self-organizing into rhythm. Nature, it seems, can choreograph even without intent. If you were drifting beside it, you'd see faint glimmers racing across its surface, jets igniting, fading, igniting again, each flash echoing across the coma like distant lightning on slow-motion replay. The silence between flares makes them more vivid. You'd feel, even through the vacuum, that this is what awakening looks like when written in chemistry instead of consciousness. Perhaps that's why the scientists watching could not help but anthropomorphize. "It switched on," one said, shaking his head, like it decided to wake up. The phrasing stuck because it fit the data. No slow ramp, no ambiguity. Just one moment quiet, the next alive. And somewhere in that binary pulse, off, on, lies the secret of how matter remembers energy. A comet built in darkness, carrying a spark that refuses extinction, waiting for its cue from a distant star. The switch isn't mechanical, it's elemental. When light touches it, everything begins again. Something decided to wake up. Every comet's path tells a story of where it came from, and 3I Atlas moves unlike anything native to our solar system. Its orbit isn't an ellipse, but an open arc, a hyperbola that cuts through the sun's gravity well and will never return. That alone speaks of exile. Most comets are loyal visitors, drawn back by gravity to repeat their frozen pilgrimage. This one is a wanderer, unbound, moving at more than 100 kilometers per second relative to our star. Its speed is the mark of something born far beyond our neighborhood. When astronomers traced its inbound trajectory backward, the path didn't point toward any known stellar system. It pointed upward, out of the plane of the Milky Way, from the ancient region we call the thick disk. The thick disk is a kind of galactic fossil, a band of stars so old they glow red with age, low in metals and rich in memory. The stars there formed more than 10 billion years ago, long before the sun existed, when the galaxy was young and turbulent. Their chemistry is simpler. Their ratios of iron to hydrogen low. Their dust poor in the heavy elements that later worlds require. If 3I Atlas truly came from that region, then its building blocks were laid down in a different epoch of the Milky Way's life. In the thin disk where we live, stars are younger, brighter, heavy with metals forged in generations of supernova. Our planets and comets are built from that abundance. But in the thick disk, the rules were leaner. Fewer heavy atoms meant fewer pigments for worlds to paint themselves with. The result is matter that behaves oddly in our environment, reacting to sunlight and space in ways that feel unfamiliar. 3I Atlas carries that signature, a body formed in scarcity, now wandering through a realm of excess. Its chemistry acts out of place because it is out of place. Think of it as a stone carved in a forgotten dialect. Every molecule, every spectral line, speaks in that accent. The nickel without iron, the cyanide that blooms late, the sudden flares of light. All could be the habits of an ancient chemistry shaped by slower suns. When we observe it, we aren't just seeing a comet, we are seeing the relic of a galactic migration. Its motion is the memory of a collision between epochs. To imagine its journey is to imagine time stretched across space. Picture an object forming near a dying star, drifting through a crowd of ancient suns, ejected by a gravitational nudge that sent it on a voyage across hundreds of light years. It would have wandered the void for ages, frozen and silent, until one day it crossed paths with the solar system, a visitor from a slower, dimmer neighborhood. The dust coating its surface could contain the first whispers of chemistry that preceded life itself. Every outgassing molecule we measure is a page from that primordial record. In a way, 3I Atlas is a time capsule of the galaxy's youth. When it passes through the sunlight of a younger system like ours, it carries both contrast and continuity, a reminder that the Milky Way is not a single age, but a tapestry of different eras still spinning together. Its presence tells us that even across billions of years, material memory endures. So, when the data modelers at NASA describe its source as consistent with a thick disk origin, they are saying something poetic in the language of restraint. They are telling us this visitor may have been born when the galaxy itself was still learning to make stars, before the metals we take for granted existed in abundance. It is a messenger from that simpler time, composed of the raw, unembellished elements that built the first planets. Older than our sun, older than our myths, it crosses through our sky like a slow echo. And when it leaves, it will keep traveling upward, back toward that quiet galactic plateau where its kind still drifts unseen, a stone carrying the memory of a vanished age. It came from a place where stars die slowly. When scientists first examined the chemical ratios from 3I Atlas, the numbers didn't just look unusual. They read like a code written backwards. In ordinary comets, water is the loudest voice, with carbon dioxide a faint harmony in the background. Here, it was reversed. CO2 dominated every spectrum, drowning out water by a factor too large to ignore. The ratios looked upside down, as if someone had rearranged the priorities of creation. For a moment, the data team thought it was contamination, but each instrument confirmed the same truth. This comet carries a cargo that defies the rules of our solar system. Carbon dioxide should only become dominant when ice is scarce or deeply buried, yet 3I Atlas was venting it freely even before it neared the sun's heat. That suggests a strange architecture beneath its crust. Layers arranged like pages in a book, each responding to light in a different way. The first layer whispered carbon, the next sang oxygen, the third exhaled nitrogen laced with cyanide, a chemical symphony unfolding measure by measure. One scientist called it a suitcase unpacking itself in sequence. The image stuck. Every jet, every plume, was a story opening to the next. But the most puzzling clue was timing. Cyanide emissions, the green breath often seen early in comets as sunlight first touches their ice, appeared here much later. It was delayed, as if the molecule had been waiting its turn. Cyanide, so toxic to us, plays a key role in the chemistry that can give rise to life. On early Earth, reactions involving cyanide may have built the first amino acids, the bricks of proteins. Seeing it awaken late rather than early turned the usual script inside out. Cyanide, but too late. Why? Perhaps, researchers speculated, the structure of 3I Atlas hides its volatile compounds behind layers of less reactive material. Sunlight has to peel it open like wrapping paper, each stratum revealing a different set of molecules. The behavior fits a model of stratified ices formed under alternating conditions. Warm, then cold, then irradiated in interstellar space. The outer shell could be ancient dust hardened by cosmic rays. The next layer, frozen carbon dioxide. Then a deeper pocket rich in nitrogen and organics. When the inner chamber finally cracks, cyanide escapes, as though the comet exhales a secret too intimate for its first breath. To watch such chemistry is to glimpse something that feels intentional. The pattern is precise, not random. Ratios shift in steps, not gradients. That precision is why some researchers describe 3I Atlas as performing rather than merely reacting. Its chemistry behaves as if it's performing, rehearsed, layered, unfolding on cue. This isn't consciousness. It's complexity tuned by physics older than biology. Yet the impression lingers. Maybe life is just this, the universe learning to choreograph matter with purpose. If we could slice through the comet's nucleus, we might see those layers stacked like the sediment of forgotten oceans. Each one a frozen snapshot of conditions that existed before our sun was born. There, deep inside, carbon chains twist in silence, preserved since the galaxy's first bloom of stars. Some of these molecules, formaldehyde, methane, cyanide, are not random debris. They are the alphabets of chemistry that writes itself into life whenever conditions allow. It is possible, even likely, that the comet carries compounds that once drifted through the birth clouds of other worlds, seeding them with potential. That idea, chemical seeding, is older than any myth of creation. Life, according to it, is not a single origin, but a habit of matter. When comets like 3I Atlas pass through new systems, they leave behind fragments of that habit. Carbon dust, amino precursors, frozen codes waiting for warmth. To imagine its wake is to imagine a trail of possibility stretching across interstellar distances, a whisper of life's handwriting scattered through space. And so the comet's strange chemistry becomes more than anomaly. It becomes a hint at continuity, a message that the conditions for complexity are not unique to us. In a universe built on reaction, maybe some reactions learn to persist, to respond, to perform. Perhaps life itself began not as accident, but as performance, a behavior repeated until it remembered itself. The scientists studying 3I Atlas would never phrase it that way in their papers, but the wonder seeps through the margins of their language. Ratios, volatiles, phase transitions, all clinical terms for something quietly miraculous. A living chemistry, acting out its script across billions of miles. This is the cargo it carries, not just molecules, but memory. Not just gas and dust, but the ancient rhythm of cause and response that might one day breathe again on another world. Every puff of vapor is a rehearsal, every spark a reminder that matter can mimic intention. Its chemistry behaves as if it's performing. Every discovery begins with someone who refuses to look away. 3I Atlas may have crossed the eyes of professional telescopes first, but it was kept alive in the hearts of those who stayed up long after midnight. Citizen astronomers, scattered across continents, their lenses pointed at the same patch of sky. They call themselves watchers, not scientists, though many have logged more hours of observation than most researchers ever could. They are the quiet ones who trade sleep for wonder, chasing faint signals from worlds that may never return. When the comet began its unpredictable flares, the alerts didn't come from observatories, but from backyards. A man in Poland noticed the green halo of cyanide brightening faster than expected. He posted a note on an amateur astronomy forum. 3I Atlas just jumped in brightness by a full magnitude. Within minutes, telescopes from Spain, Chile, and Australia confirmed it. The anomaly that would later intrigue professionals was first spotted by an insomniac with a small Schmidt-Cassegrain scope and a knack for noticing what doesn't fit. His discovery spread through online chat rooms like the soft ringing of a bell. Science had just blinked awake because someone, somewhere, didn't close their eyes. That moment revealed something profound about how knowledge grows now. It no longer belongs solely to institutions. The sky is too wide, the data too vast, for a handful of eyes to catch it all. Every night, thousands of watchers contribute images, brightness measurements, timing logs, small offerings that, when assembled, become a portrait of the universe breathing. Their data streams merge into repositories where algorithms and humans sift side by side. The frontier isn't a single telescope on a mountain anymore. It's a network of curiosity stretching around a spinning planet. Some of these watchers work from cities where the sky glows orange with pollution. They compensate with narrowband filters and patience. Others set up portable rigs in deserts, fields, or icy lakes, chasing darker skies. They compare notes like musicians tuning to the same key. When 3I Atlas flared again, hundreds of amateurs noticed a subtle asymmetry in the coma, the gas cloud bending slightly as if pushed by something unseen. Professionals later confirmed it. Asymmetric outgassing due to rotating jets. The discovery belonged to everyone. There's a certain intimacy in that collaboration. The data points on a graph carry fingerprints of people sitting in silence, wrapped in blankets, waiting for a star to clear the horizon. One observer in South Africa described the experience. It's not about owning the discovery. It's about feeling the universe notice you back. His words capture something the numbers can't. The act of watching becomes its own reward, an echo of 3I Atlas's own behavior, responding to attention, glowing more brightly when seen. A comet watched by thousands of hearts. The world of citizen science isn't glamorous. It's patient, repetitive, humble. Yet it has changed how we understand the cosmos. The amateur images that once filled folders now fill databases used by professional researchers. When artificial intelligence learns to classify comets, it learns from the collective patience of those who logged them. Every pixel measured in a backyard becomes part of a larger intelligence, the kind that no single person could hold. Science, once a solitary pursuit, has become a choir, and perhaps that's the most beautiful symmetry of all. As 3I Atlas performs its chemical awakenings and spectral songs, humanity mirrors it with its own choreography. People waking across time zones, cameras activating, messages crossing oceans. The comet acts, the watchers respond, the data sings back. It's a feedback loop between curiosity and cosmos. Sometimes, to see the acting sky, you need many eyes. Among those eyes was a young student from Brazil who caught an ultraviolet flicker no one else had seen. Her images, when processed, revealed a rare cyanide emission that lasted less than 2 hours. It would have gone unnoticed if not for her persistence. When asked why she was watching that night, she said simply, "I couldn't sleep." In that small confession lies the spirit of discovery. Sleeplessness transformed into vision. Those who sleep less often see the greatest things. Each observer becomes a pixel in a grand mosaic. Each lens a reminder that discovery doesn't belong to institutions, but to attention. This is how science survives, by sharing the act of noticing. The more eyes turned upward, the more complete the picture becomes. The comet isn't a distant object anymore. It's a shared moment. And through those shared moments, we glimpse our collective reflection, a species learning to see together. If 3I Atlas behaves like a performer, then humanity is its audience and its partner. Every measurement, every photograph, every gasp of wonder feeds back into the performance. The comet reacts to sunlight. We react to the comet. The light that left it hours ago reaches thousands of retinas, thousands of screens, turning data into emotion, and back again. The result isn't just observation, it's participation. Perhaps that's what makes this story feel so human. A piece of rock and ice traveling through infinite dark manages to connect strangers who will never meet. It reminds us that even in the most isolated corners of the universe, Awareness spreads through shared attention. The watchers keep their eyes open, and the comet keeps acting, as if both understand the same unspoken rule. Things exist most vividly when seen. We are all part of its performance. It began, as so many curiosities do, with a coincidence. On the same week, 3I, Atlas, flared near the orbit of Mars. Mercury reached its greatest elongation, and the dwarf planet Ceres lined up almost perfectly in the same celestial longitude. For skywatchers tracing their paths, it looked deliberate, a choreography across the ecliptic. A few online maps even plotted the overlap, captioning it with excitement. Mercury, Ceres, and the interstellar visitor all in phase. It sounded like a secret alignment, a coded message from the cosmos. But astronomy is generous with patterns, and the human mind is greedy for them. We crave symmetry, rhythm, alignment. It feels like understanding. That craving has a name: pareidolia, the tendency to see shapes where none were intended. Faces in clouds, animals in constellations, messages in random noise. It's an inheritance from survival. Recognizing patterns kept our ancestors alive. Yet the same instinct that saw predators in tall grass now sees design in the dance of planets. The mind wants meaning, even where there's none. There's comfort in that impulse. To imagine the universe arranging itself into stories just for us softens the distance between us and it. When we see Mercury racing ahead, Ceres lingering behind, and a comet crossing between them, we feel narrative, a beginning, a middle, an end. The rational explanation, that these orbits simply intersect in projection, feels dull compared to the poetry of coincidence, so we reach for the poetry anyway. Coincidence is the universe's smile, an accidental grace that asks for nothing but a glance. Scientists, of course, tread carefully between awe and assumption. They map these alignments with precision, then remind themselves not to assign meaning. A pattern isn't proof, it's a prompt. Still, even the most disciplined researcher isn't immune to that flicker of wonder. When three wandering bodies share a frame, it's hard not to imagine a cosmic conversation taking place just beyond the edge of comprehension. Maybe that's why astronomy attracts poets and physicists in equal measure. Both are trying to listen. In the quiet rhythm of observation, the data flows in clean numbers. 3. Atlas brightens. Mercury fades. Ceres glows faintly, each obeying gravity and light without secret intention. Yet from Earth, their motions overlap in a harmony that feels almost human. Call and response across millions of miles. The mind supplies the melody. We see faces in the stars, not because they're there, but because we need to belong to something vast enough to hold us. Psychologists have long known that pattern seeking helps us cope with uncertainty. When life feels random, meaning is an anchor. The same applies to the cosmos. Each alignment, each strange echo of timing, offers reassurance that the universe isn't just indifferent machinery, but a kind of living pageant, rich with symbols waiting to be decoded. Whether it's true doesn't matter as much as the feeling it gives, that we are participants, not spectators, in the motion of the heavens. Still, it's important to pause and smile back at our own imagination. 3 Atlas doesn't know that Mercury and Ceres shared its stage. Their orbits intersect only in the flattened map of our sky, not in space itself. The beauty lies in perspective. How the view from one small world can transform coincidence into art. It's like hearing a random chord that happens to sound perfect. The music isn't planned, but the harmony is real. For those who tracked the alignment, the experience became personal. One observer wrote, "It felt like the universe winked." Another said, "It's just math, but beautiful math." That's the quiet truth beneath pareidolia. Even when our minds invent patterns, they can still lead us to appreciation. The joy isn't in being right, it's in noticing. Seeing order, even briefly, in a sky ruled by chance reminds us that perception itself is a gift. So the segment of 3I Atlas's journey that overlaps with Mercury and Ceres will live in our records as an alignment that meant everything and nothing. It inspired hundreds of sketches, time-lapse videos, poems, and journal entries, even though the physics behind it was mundane. The comet didn't wink. We did. We projected our stories onto a stage of light and motion, and in return, we felt seen. There's no harm in that. Wonder doesn't require justification. What matters is the balance, the ability to marvel without mistaking beauty for message. The universe performs, we interpret. Between those two acts lies the conversation that keeps astronomy alive. It teaches us humility. Not every coincidence is a sign. Not every alignment a prophecy. Sometimes it's just geometry doing what geometry does. But when you step outside at night and notice 3 points glowing in near symmetry, let yourself feel it anyway. The soft pull of connection, the small thrill of recognition. You don't have to believe it's deliberate to know it's beautiful. Coincidence is enough. Coincidence is the universe's smile. In October 2025, something didn't happen. Blue Origin had scheduled a suborbital flight from its West Texas launch site. Routine, unremarkable. One more step in the rhythm of private spaceflight. But the day came and went with no live stream, no press release, no celebratory post from the crew. The company's channels stayed quiet. The official feeds empty. For hours, then days, there was only silence. It wasn't an error. It was absence. And that absence made people listen harder. Online communities began to hum with speculation. Had the flight been delayed? Was there an incident? Or had it gone perfectly, but someone decided to say nothing at all? The curiosity built not from facts, but from the vacuum left behind. The mind, always allergic to blanks, filled them with stories. When no one speaks, imagination rushes in to narrate the silence. In that way, it felt oddly familiar, like the weeks when 3I Atlas vanished from telescope view, slipping behind the sun's glare. The instruments saw nothing, so the world invented what might be happening. Was the comet fragmenting? Recharging? Waiting? The truth, when it returned, was ordinary. It had simply passed through the bright noise of the star and emerged intact. But the quiet between observations carried its own weight. Silence became the story. There's something magnetic about withheld sound. In a world tuned to constant updates, stillness feels intentional. Blue Origin's quiet week drew more attention than any launch it had broadcast. Speculation bred faster than data, weaving theories out of nothing. The paradox was clear. By doing nothing, they created a louder noise than any engine could make. It's a reminder that silence isn't absence. It's an action with its own gravity. Sometimes, nothing happens. And that's the story. 3I Atlas teaches that lesson in its own way. For every flare and chemical revelation, there are long intervals where it simply drifts, emitting no light we can detect. Those are the moments that define it just as much as its outbursts. The silence of the comet, like the silence of the launch, invites projection. We imagine purpose in the pause, agency in the void, but maybe the meaning lies in restraint. In physics, energy conserved is still energy, its potential, waiting for release. Astronomers often speak of the dark time in observations, the periods between exposures when instruments reset. when no photons are being gathered. Those gaps are necessary. They allow calibration, recovery, perspective. Without them, the next image would blur. Maybe human understanding works the same way. We need pauses between revelations, darkness between lights, to make sense of what we've seen. The silence from Blue Origin eventually broke with a brief statement. Routine internal operations. No flight activity to report. Nothing more. But the fascination remained. Because the quiet itself had become a kind of performance, a mirror of our need for constant motion. In a universe that often speaks in bursts, flares, pulses, explosions, it's easy to forget that stillness has its own language. Silence can act louder than noise. It sharpens attention, stretches imagination, and reminds us that not every space needs to be filled. 3i, Atlas, drifting through its dark interval, carries that same truth. The cosmos doesn't announce itself. It waits. It lets us do the talking, then answers in its own time. So tonight, when the story slows, let it. Let the gap widen, the room fall still. Listen to what isn't being said. The absence you feel isn't emptiness. It's possibility. The universe isn't ignoring us. It's teaching us how to hear. Every generation meets its reflection somewhere in the sky. For ours, it began with Umama, the first interstellar object ever confirmed to pass through our solar system. It wasn't large or luminous, but its motion disobeyed gravity's script. It spun strangely, accelerated as if pushed by invisible hands, and for a while we whispered the oldest question we know: could it be artificial? When the data came back ordinary, the wonder didn't fade. It simply turned inward. The object had been our mirror all along, showing how quickly our minds leap from mystery to meaning. Then came Tabby's star, a sun that dimmed without pattern. People saw alien megastructures, vast machines harvesting light. The truth was dust, ordinary dust. But the dream persisted, because what fascinated us wasn't the answer. It was our own reflection in the act of searching. The same thing happens now with 3i Atlas. We measure, analyze, predict, and yet a part of us keeps hoping it might reveal something more. A story, a signal, a sign that we are not alone in the dark. Every mystery is a mirror. The more we stare into it, the more clearly we see our own longing. What do we see when we stare at anomalies? We see curiosity wearing the mask of certainty, fear disguised as fascination, wonder pretending to be proof. It's the human habit to project ourselves onto what we cannot touch. The unknown becomes a canvas for our needs. There's nothing wrong with that. It's how we navigate the infinite. We project our hope onto the stars, the way the sailors once read constellations into safe harbors. Our instruments may have changed, but the desire behind them hasn't. To explore the universe is to explore the architecture of our own perception. The comet's acting, yes, but so are we. Atlas performs its chemistry, its physics, its patient ballet through sunlight and shadow. We on Earth perform interpretation. We call its emissions responses, its light curves moods, its flares behavior. In doing so, we reveal what we value most: connection, intention, the possibility of company. We turn a block of ice and dust into an actor, because we want to believe the cosmos is aware enough to notice us. In truth, we are the ones performing awareness, rehearsing empathy on a cosmic scale. There's a quiet humility in realizing that. The act of naming, of watching, of wondering, each is an echo of our own consciousness projected outward. We're not just studying matter, we're measuring meaning. The comet is a teacher, and its lesson is simple. The universe doesn't need to speak for us to listen. We fill its silence with imagination, and imagination, in turn, becomes discovery. That is the circle. Reflection, turning into revelation. Look at the way 3I Atlas behaves. The delayed cyanide, the nickel without iron, the sudden awakenings. Each anomaly is a surface catching our attention, a mirror for our patterns of thought. We look at it and see mystery. The comet looks back through physics and shows us ourselves, creatures of pattern and wonder, forever chasing what lies just beyond comprehension. In the slow pace of the night sky, these reflections unfold like meditation. Oumuamua taught us humility. Tabby's star taught us patience. 3. Atlas teaches us participation. The cosmos doesn't perform for us. It performs through us. Our instruments, our interpretations, our emotions, all are part of the choreography. The line between observer and observed dissolves in the act of attention. To realize this is to find peace. The need for certainty fades. The need for belonging expands. We no longer demand answers from the stars. We share in their questions. Every flare of light, every silence, every coincidence becomes a conversation about being here, alive, aware, watching. The reflection extends beyond science. It touches philosophy, art, even the way we dream. The more clearly we see the universe, the more we sense its resemblance to our inner world. Its vastness mirrors our loneliness. Its order mirrors our reason. Its beauty mirrors our hope. And in that symmetry lies a kind of grace. Perhaps that's the real meaning of 3I Atlas, not as a messenger from elsewhere, but as a reminder from within, that to seek understanding is itself an act of creation. The comet travels, we interpret. The light reaches us, we answer. In that exchange, the boundary between matter and meaning blurs. The universe holds up its mirror, and for a moment, we see both faces, the comet's and our own. And we recognize that we have always been partners in the same performance, each reflecting the other's light. The comet's acting, yes, but so are we. If you think of the universe as a grand library, then comets are its books, each one carrying a fragment of chemistry, a record of conditions from a world we'll never visit. Oumuamua was the first volume to fall into our hands, slim, ambiguous, with most of its pages missing. Borisov followed a year later, thicker and more legible, a true comet written in the familiar ink of water, carbon, and dust. And now, 3I Atlas arrives as the third book in the series, written in a dialect we're only beginning to translate. Together, they form the start of a collection we never knew we were building, a chemical library of interstellar visitors. Every book smells different. Oumuamua carried the scent of mystery. No gas, no tail, only the faint perfume of speculation. Borisov smelled like home, icy, ordinary, a comet that reassured us the laws of chemistry still apply beyond our star. Atlas, though, is something else entirely. Its pages open in bursts. Nickel without iron, carbon dioxide before water, cyanide arriving late. It reads like poetry from a civilization of molecules, full of metaphors we can measure but not yet understand. Astronomers now speak of these travelers the way librarians speak of rare manuscripts. Each one is a chapter in the galactic story of formation, a preserved record of how different star systems build and store their elements. The Milky Way, after all, isn't a uniform factory. Every region has its own recipe, its own handwriting in the periodic table. When interstellar objects visit, they bring samples from their shelves. To study them is to read across cultures of creation. In a few years, this collection will grow. The Vera C. Rubin Observatory, home to the LSST, the Large Synoptic Survey Telescope, will scan the entire sky every few nights, watching for moving specks that don't belong. It will catch dozens, maybe hundreds, of interstellar objects each year. JWST will analyze their light, mapping their chemistry in exquisite detail. Some will be barren, some volatile, some carrying traces of organic molecules we've never seen before. A library taking shape in real time, bound not in paper, but in motion and light. It's easy to forget how recent this idea is. Before Oumuamua, we didn't know interstellar visitors existed in detectable numbers. The odds seemed tiny. Now we suspect they're everywhere, millions drifting between stars, silent couriers from long-dissolved worlds. Most pass unnoticed, faint as dust, their stories unread. We've only just learned to open our eyes wide enough to see them. The galaxy writes letters. We just started reading. When 3I Atlas flared and sang its strange spectral notes, it wasn't just performing for curiosity's sake. It was adding to the archive, a data point in the growing anthology of cosmic origins. Its ratios and timings, its carbon chemistry and layered architecture become reference entries for a science that's still in its infancy. We are building not a telescope catalog, but a universal glossary of how matter behaves when freed from the influence of a single sun. Imagine the shelves of this cosmic library stretching across centuries of discovery. Oumuamua, the preface, silent, sleek, unsolved. Borisov, the control, familiar, chemical, our baseline for the ordinary. 3I Atlas, the breakthrough, complex, unpredictable, rich in paradox. And the next, maybe a body made of ammonia ice, or a crystalline sphere that reflects starlight too evenly, or a comet that carries the spectral fingerprint of sugars. Each new object will rewrite our definition of possible. Every book in this library will change the language of astronomy a little more. Already, our metaphors are evolving. We talk about reading light curves, translating spectral lines, listening to molecular signatures. The verbs of literature and art fit the cosmos better than the verbs of engineering, because what we're doing is interpretation, not control. These travelers don't arrive for us. They simply pass by, and we catch what fragments we can before they fade again into interstellar night. Yet there's a joy in that impermanence. The brevity makes the reading sweeter. To watch a comet glow and vanish is to glimpse a sentence from a book that will never be fully written. And still, we keep reading. Because each fragment tells us something about the way matter remembers, the way atoms preserve the rhythm of their first forge, the way chemistry carries intention without needing mind. We're learning to see not just stars as archives, but comets as couriers, each one a message in a bottle from the stars. When you think of it like that, the universe feels smaller and more connected. Every interstellar object that crosses our path reminds us that we share materials, not just space. The oxygen in our lungs may once have spun around another sun. The carbon in our cells may have ridden through cosmic dust from some vanished system. To study 3I Atlas is to read our ancestry in a different script. Soon, telescopes will give us hundreds of these scripts, hundreds of alien chemistries, and somewhere among them, maybe, will be one that matches our own. The same balance of water and carbon, the same hints of organic chains that whisper of life. The moment we find that resonance, we'll understand something profound. The galaxy isn't just a place we live. It's a conversation we're part of. The library is open, and 3i Atlas has just added a new volume to its shelves. As we keep reading, the question won't be whether there are more books out there, but how many we have yet to learn how to see. Each comet is a message in a bottle from the stars. In the quiet glow of 3i Atlas's spectrum, the faint line of nickel persists, a thread of light that refuses to fade. Its partner, iron, is gone, dissolved into silence. What remains is the signature of endurance, the trace of a metal that remembers its birth. Nickel speaks the language of stars. Every atom of it was forged in the collapse of a sun far older than ours, in the furnace of a supernova, where matter met energy and became history. When that ancient star died, it scattered its story into space. Iron, nickel, cobalt, all flung into the dark like sparks from a forge. Most of those sparks cooled, found new homes in dust and planets, or sank into the cores of worlds. But some, like the atoms within 3i Atlas, escaped entirely, carrying the memory of that death across time. They are travelers made of endings. To see nickel shining now, millions of years later, is to see that memory made visible. Iron rusts away under exposure. Nickel endures. In the cold of interstellar space, it outlasts its sibling, holding the pattern of the explosion that birthed it. That's why scientists call it a tracer, a way to read the chemistry of lost stars. Where nickel appears without iron, you're looking at material shaped by extremes, frozen before equilibrium could return. It's as though a single phrase from a cosmic sentence survived, floating toward us. Nickel is memory. Not the kind stored in neurons, but the kind etched into structure. The slow remembrance of how energy once moved through matter. Each spectral line we measure is a syllable in that language, a relic of pressure, temperature, and light. The comet carries it faithfully, like an archive of stellar handwriting. When its spectrum flares with that lonely element, we aren't just seeing metal. We're seeing persistence, the will of atoms to retain their origin story. Some researchers believe this peculiar ratio, nickel bright, iron faint, could only come from a star that cooled too quickly after its explosion. In such a place, iron would condense and sink, while nickel remained aloft, clinging to dust grains that drifted into space. Those grains might have joined others, coalescing into a comet nucleus. Billions of years later, sunlight awakens them again, and the nickel sings its old tune. Every metal remembers where it was forged. The message it carries isn't linguistic, but it feels intentional nonetheless. The universe communicates through endurance. A supernova's brief light fades, but its debris continues the conversation, slowly, quietly, chemically. 3i Atlas, in that sense, is a messenger from a long extinguished fire. Its existence tells us that destruction and creation are one continuous act, that memory is built into the very bones of matter. Think of what that means. The atoms in our blood, in our coins, in the instruments that detect this comet, share ancestry with that same nickel. The line we see in its spectrum is echoed in us. We are reading our own genealogy, written in another body. The light that left it travels through the dark, touches a mirror in our telescope, and finally rests on our eyes. A circuit of recognition completed. When we say nickel without iron, we're describing the universe remembering itself. If the cosmos ever speaks, it speaks like this, through endurance rather than words, through repetition rather than revelation. Nickel survives because it resists corrosion, because it can hold shape while others dissolve. That endurance is what allows us to find it at all. And so the element becomes a symbol, a reminder that the universe, vast and ancient, still keeps its records in tangible form. Nickel is memory. It glows not with the brilliance of novelty, but with the quiet persistence of recollection. It tells us that the same forces that birthed stars also built the scaffolding of our own existence. The same explosions that forged the metals in 3I Atlas forged the metals in us. We are bound to it by chemistry, by time, by the shared language of endurance. When the comet finally fades from view, the memory remains. It's encoded in data, in light, in the atoms we already share. The message isn't about alien intention. It's about continuity. Life, like metal, is what the universe uses to remember itself. 3I Atlas carries that truth through the cold, a shining whisper from a fire that once burned brighter than a billion suns. Every metal remembers where it was forged. Between the stars drifts an invisible ocean of worlds. Not planets with atmospheres and gravity, but smaller, colder voyagers. Billions of fragments of forgotten systems, moving silently through the dark. Astronomers call them interstellar objects, and if 3I Atlas is one, it's not alone. Far from it. For every one we've spotted, there may be millions we've missed, each gliding between suns like an unrecorded word in the story of the galaxy. Until recently, we had no reason to believe they existed in such numbers. The cosmos felt empty between the stars, a quiet vacuum. But new models tell a different tale. The dark isn't empty, it's crowded. Computer simulations suggest that every system ejects debris when it forms. Comets, asteroids, shards of rock and ice. Most drift away forever, freed from gravity, building a population that fills the galaxy like dust motes in a beam of light. Earth crosses that beam every year, and sometimes one of those motes glimmers just bright enough for us to see. The LSST, soon to be known as the Vera C. Rubin Observatory, will change everything. When it begins full operation, it will scan the entire southern sky every few nights, mapping movement where we once saw stillness. Its mirrors will catch faint trails invisible to older instruments, tracing objects as small as 100 meters across, wandering faster than local comets could ever move. What was once invisible will become a field of motion, a map of wanderers. Each new detection will be a tiny discovery, another piece of the hidden population revealed. And it won't work alone. The Square Kilometer Array, SK, will listen to the radio silence between stars, capturing electromagnetic echoes that might betray dust clouds, plasma tails, or other traces of these travelers. Together, vision and hearing will merge into a single awareness, like eyes opening in the dark. When those signals arrive, they'll sound like faint pings on a radar, soft, rhythmic, distant. Ping, ping, another world passing by. Another story waiting to be read. We are just now turning on the lights. The idea that space between stars could be populated challenges our old imagination of emptiness. It means that the galaxy isn't a barren expanse, but a living continuum, stitched together by motion and memory. These objects carry pieces of their home systems: minerals, frozen gases, isotopic fingerprints. Some may even carry prebiotic molecules, the same kind that dance in 3I Atlas's tail. Each one is a messenger, proof that creation doesn't stay confined. It drifts, it shares, it connects. When LSST begins its nightly symphony of exposures, data will flow like water. Thousands of streaks across digital skies, each one a new object, a new coordinate, a new fragment of somewhere else. Machine learning algorithms will sift through them, identifying which are native to our sun and which came from beyond. In that vast catalog, patterns will emerge, clusters of motion hinting at unseen origins, families of travelers born from the same lost systems. The hidden population will start to take shape, not just as numbers, but as a community of worlds. And when we finally map them all, we'll see the galaxy as it really is. Not a desert, but an ocean. Our solar system is just one current in that ocean, its boundaries blurred by endless motion. Somewhere out there, an object from another star is crossing the space our system will occupy centuries from now. Some of them may already have visited, leaving microscopic dust as postcards of their passing. Some may even be watching in their own way, reflecting sunlight across distances so vast that detection feels like destiny. How many are watching us back? That question isn't paranoia, it's poetry. Every object out there reflects light, and reflection is a kind of gaze. We observe them, but they also illuminate us, teaching us to look deeper, to widen our sense of belonging. Discovery is only a matter of light. The more we shine, the more we see. Someday soon, we'll know their numbers. We'll hear their pings in data streams, watch their trails appear in survey scans, maybe even send probes to intercept one as it passes. When that happens, humanity will no longer stand at the edge of the galactic stage. We'll be inside it, part of the motion, part of the crowd. The hidden population will become visible, and we'll realize we were never alone in the void. We were simply in the dark, waiting for the lights to come on. Discovery is only a matter of light. We live in an age where the strange is no longer rare. Every night, telescopes pour torrents of data into the world, and somewhere within those billions of lines, there is always something that doesn't fit. A flare too bright, a signal too sharp, a curve that bends against expectation. Once, such moments of uncertainty were sacred. They were invitations to wonder. Now, surrounded by infinite information, we chase them like sparks, forgetting that even wonder can be exhausted. We have become addicted to anomalies. The more we find, the more we need. Each new irregularity feels like a hit of possibility, a doorway into revelation. But when discovery becomes consumption, mystery loses its weight. We scroll through the cosmos the way we scroll through our feeds, looking not for understanding, but for stimulation. The universe becomes content, and the quieter truths, the ones that require patience, get lost beneath the noise. Online, a rumor spreads faster than light. One unusual spectrum, one unexplained pulse, and suddenly the web fills with theories, alien signals, hidden technologies, secret physics. The human mind leaps from unexplained to extraordinary in a single heartbeat. We tell ourselves we're open-minded, but often we're just impatient. We want meaning before we have context. In our hunger for answers, we sometimes forget to ask better questions. It's not just science that's changed, it's culture. The tools that let us see deeper into space also let us share faster than we can think. Every anomaly becomes a headline, every mystery a product. We live in a time when even curiosity has an algorithm. But the truth is quieter. Real discovery unfolds slowly in margins and revisions, in years of watching and waiting. Mystery isn't entertainment, it's endurance. That's why we return to voices like 3i Atlas. Its strangeness reminds us of how to wonder properly, without urgency, without conclusion. It shows us that not every oddity demands explanation. Some are simply reflections of the limits of what we can measure. Some are lessons in humility. When anomalies multiply, it isn't the universe growing stranger, it's us learning to look closer. There's a phrase that captures this balance. Not every strange thing is a sign. Some are lessons. We don't have to decode every flicker of light to feel its significance. The lesson might not be what it means, but how we respond. Mystery should calm us, not consume us. It should remind us that we are part of a story still being written, one where suspense is the point, not the problem. The pattern repeats across time. In the early 1900s, people mistook radio noise for Martian messages. In the 1960s, pulsars were first labeled LGM, Little Green Men, because their regular signals seemed too perfect to be natural. Each time, reality proved more grounded, but never less beautiful. The real wonder wasn't in the fantasy, but in the persistence. The way we kept listening, kept refining, kept learning to tell our imaginations apart from truth. The same applies now, in the digital era. Data floods us, but wisdom arrives drop by drop. Perhaps the most extraordinary thing about anomalies isn't their existence, but our reaction to them. The universe behaves as it must. We are the ones who behave as if it should surprise us. In that sense, humanity itself is the strangest phenomenon, a species that insists on turning uncertainty into art. Confronted with randomness, we compose patterns. Faced with silence, we make stories. We are the anomaly that dreams. To live with mystery, then, is to accept ourselves. To understand that the unknown isn't a threat, but a teacher. To resist the reflex to fill every gap with noise. The next time a strange reading appears in the data, a sudden brightening, a radio burst, an object that moves like it knows it's being watched, let it breathe. Let it exist without an immediate label. The pause between knowing and naming is where meaning forms. The more you learn about the universe, the more it teaches you patience. Not every light is a signal. Not every silence a secret. Sometimes, the mystery is enough. It came quietly, and it will leave the same way. Atlas, the interstellar wanderer that once drew our eyes upward, now drifts back toward anonymity. Its brightness fades a little more each night. The tail that once fanned out like a banner of discovery thins to a whisper of light. Soon it will pass beyond the range of even our most patient telescopes, dissolving into the background of the stars. It came, acted, and left, just like us. What remains is not the object itself, but the echo of attention it inspired. Every measurement, every image, every sleepless night of observation now exists as memory. The record of humanity watching something it cannot touch. The data will survive longer than the glow, archived in servers and publications. But what we keep most vividly is the feeling, the awareness that we once shared a moment with a traveler from the dark. As 3i Atlas recedes, we begin to see the pattern it traced in us. The Comet's story was never just about chemistry or motion. It was about the way we respond to the unknown. With curiosity, imagination, reverence. We called its outgassing behavior, its flares reactions, its silences pauses. But all along, we were describing ourselves, the human impulse to act, to react, to seek meaning in motion. The comet was only the mirror. We were the movement reflected. It came, acted, and left, just like us. The universe is full of performances like this. Stars flare, planets spin, atoms collide, and every event is both expression and response. Nothing acts alone. Every photon that leaves the sun meets an atom that listens. Every gravitational tug is answered in kind. It's a conversation that has no audience because everything participates. Even silence has its line to speak. When we say 3, Atlas acted, what we really mean is that it entered the dialogue, was shaped by forces, yes, but it also shaped in return. Its chemistry responded to sunlight. Its structure sculpted the light we saw. Every molecule that escaped its surface altered the space around it. Action ripples outward, and reaction ripples back. The same is true of us. Every thought, every observation, every breath is part of a chain of cause and consequence that began long before we were born and will continue long after we fade. Acting is listening. Listening is life. Somewhere deep in that symmetry lies the quiet truth of this journey. For 15 parts, we've watched, measured, wondered. We've treated the comet as a teacher, a question, a metaphor. But perhaps it's more accurate to say it was a partner, one half of an exchange we didn't know we were having. When we looked at it, it looked back through physics, through reflection, through the simple miracle of light returning to its source. The act of observation completes the circle. The universe acts, and we answer. The more we learn about the cosmos, the clearer it becomes that separation is an illusion. We are not outside looking in. We are inside, looking around. The elements in our bodies are the same ones burning in the hearts of stars. The water that cools our skin once drifted as vapor in the void. The iron in our blood carries the memory of supernovae. The act of living is not separate from the act of the universe existing. We are its expression, just as 3 Eyes Atlas was. Think of that connection. A comet made of dust and ice from a dying system travels for millions of years through the dark. It crosses our path for a brief moment, interacts with our light, and moves on. We do the same. We are travelers through time, passing through one another's orbits, leaving trails of experience, data, emotion. To exist is to perform, to influence and be influenced, to give and to receive. The comet teaches us this not with words, but with the rhythm of its fading tail. As it slips away, the scientists who studied it return to their routines. The world keeps spinning. But in small observatories and quiet living rooms, a few people still look up at the place where it used to be, not searching, just remembering. There is comfort in that, knowing that something so brief can still leave an imprint on consciousness. The feeling is not loss, but gratitude. The performance may be ending, but the music lingers in the air. When the universe acts, we answer. That is the thread connecting galaxies to thought, atoms to awareness. Every movement calls for an echo, and in that echo, meaning forms. We are the universe's way of hearing itself. To observe is to participate. To imagine is to respond. To dream of the stars is to extend the conversation beyond matter into mind. So let the comet go. Let it drift back into the sea of unmeasured light. Its path will continue, crossing other suns, other watchers. Somewhere, centuries from now, another species may detect the same faint line of nickel, the same improbable flare, and wonder what it means. And perhaps they too will learn that the message was never in the data, but in the act of listening. Because to listen deeply is also to act. To pay attention is to shape the world you perceive. Every question asked is a force applied to reality. Every answer found reshapes the boundaries of ignorance. The dialogue never ends, it only changes voices. So now, as 3i Atlas fades from view, let its silence speak. Let it remind us that action and observation, expression and reflection are not opposites but partners. The comet glows because we look. We look because it glows. Awareness completes the circuit. And when you step outside tonight and lift your gaze, remember that you are part of this same cosmic conversation. The stars are performing, yes, but so are you. Every breath, every thought, every quiet act of attention adds to the music. The sky is not above you. It is within you, unfolding through the awareness that sees it. It came, acted, and left, just like us. And in that shared rhythm, the universe finds its voice. Good night, cosmic performer.